For decades, futurists made a seemingly logical prediction about artificial intelligence. They hypothesized a strict hierarchy of automation. First, machines would take the dangerous, heavy blue-collar jobs. Next, they would master routine white-collar tasks. Only at the very end, perhaps centuries later, would they touch the sacred realms of art, poetry, and high-level cognitive synthesis. But looking at the landscape today, the exact opposite has happened. AI is generating award-winning illustrations in seconds and writing passable code, while we still lack a robot that can reliably clean a toilet or fix a leaking pipe. Welcome to the Great Reversal. This reversal directly threatens a very specific demographic, the archetypal middle-class knowledge worker. Let us define this as the 20,000 a month cohort, representing a solid, comfortable middle-income tier globally, whether that is 20,000 RMB in Shenzhen, or roughly $80,000 a year in Silicon Valley. These are the junior software developers, data analysts, copywriters, and mid-level accountants. Their economic value has historically been rooted in a specific capability, processing information, applying standardized logic, and outputting structured results. They are the human equivalent of APIs. What we are witnessing is not a uniform destruction of jobs, but a violent hollowing out of the middle. The job market is transforming from a stable bell curve into a precarious barbell. On one end, highly paid strategic orchestrators. On the other, low-paid physical service workers. The middle layer, the processor class, is evaporating. To understand why this is an inevitability of physics and mathematics, not just a temporary economic fluctuation, we must first look at the mechanics of past industrial revolutions. Historically, whenever technology displaced labor, economists invoked the Luddite fallacy. In the 19th century, textile workers smashed power looms, fearing permanent unemployment. Yet, automation of physical power ultimately lowered the cost of goods, increased aggregate demand, and created entirely new categories of jobs. This is known as skill-biased technological change. The machine amplifies the productivity of the skilled human, raising their wages. But there is a hidden variable in this historical comfort blanket: previous machines replaced physical energy. They did not replace cognitive synthesis. To rigorously define what is happening, we turn to the ALM model, proposed by economists David Autor, Frank Levy, and Richard Murnane in 2003. They divided all human labor across two axes, routine versus non-routine, and cognitive versus manual. Let us map this out. A factory assembly worker is routine manual. A janitor is non-routine manual. A CEO is non-routine cognitive. And our middle-class knowledge worker? They fall squarely into the routine cognitive quadrant. They follow established rules to process information. In the 1980s and 90s, computers began attacking the routine cognitive quadrant. But they were limited by deterministic programming. A human programmer had to explicitly write every if-then rule. Therefore, early software could only automate tasks with rigid, perfectly defined parameters, like basic arithmetic or data storage. The middle-class worker survived because they handled the fuzzy, routine tasks, reading an ambiguously worded email and summarizing it, or drafting a standard legal contract based on a client's messy notes. This survival equilibrium was shattered by the advent of deep learning, and specifically, the transformer architecture introduced in 2017. We moved from deterministic if-then logic to probabilistic latent spaces. AI no longer needs explicit rules. By ingesting trillions of tokens of human text, it constructs a high-dimensional mathematical representation of human language and logic. The fuzzy, routine tasks, the exact domain of the middle-class knowledge worker, are now just vector math. Let us dive into the hardcore math of why this works, specifically the attention mechanism. Imagine you are a junior analyst reading a 50-page financial report to find the key risks. How do you do it? You hold a specific question in your mind, scan the text for relevant context, and extract the value. The transformer does exactly this using three vectors: query, key, and value. The query is what the network is looking for. The key is the label of the information available. And the value is the actual content. The core of this cognitive displacement lies in one elegant equation: attention equals the softmax of Q times K transpose, divided by the square root of the dimension of K, all multiplied by V. When the query vector takes the dot product with the key vector, it calculates a similarity score. The higher the dot product, the more mathematically aligned the concepts are. The softmax function then forces these scores into a probability distribution summing to 1. This tells the AI exactly how much attention to pay to every single word in relation to every other word. Why is this equation so devastating to the middle-class job market? Because it mathematically replicates synthesis. For centuries, synthesizing information, connecting disparate dots, summarizing context, and generating a coherent response, was a uniquely biological process. It required a human prefrontal cortex. Now, synthesis is a computable function. And in economics, whenever a previously scarce resource becomes computable, its marginal cost drops asymptotically to zero. Let us map this crossover point. A mid-level programmer costs a company roughly $300 a day. They can write, debug, and synthesize perhaps 200 lines of production-level code. An advanced large language model can generate, refactor, and explain thousands of lines of code for mere cents in API calls. We are not talking about a 10% efficiency gain, we are looking at a 10,000-fold reduction in the cost of routine cognitive labor. The economic gravity here is absolute. But wait, if AI is so powerful, why do we still need humans to pour coffee or install drywall? This brings us to Moravec's paradox, formulated by Hans Moravec in the 1980s. The paradox states that high-level reasoning requires very little computation, but low-level sensorimotor skills require enormous computational resources. It is easy to make computers exhibit adult-level performance on intelligence tests or playing chess, but difficult or impossible to give them the skills of a 1-year-old when it comes to perception and mobility. The logic behind Moravec's paradox is rooted in evolutionary biology. Mother Nature spent 1 billion years optimizing our sensorimotor systems. The neural circuitry for walking, balancing, and recognizing objects has been relentlessly refined by natural selection. Abstract thought, mathematics, logic, writing, is a very recent evolutionary hack, perhaps only 100,000 years old. Because it is so new, it is simple. Because it is simple, it is easy to reverse engineer in a neural network. We are automating the top of the brain first. This is why the plumber, the electrician, and the nurse are currently safe from the AI wave. Their jobs reside in the non-routine manual quadrant. Every leaking pipe is uniquely rusted, every patient's body is different. The physical world is infinitely variable and highly unstructured. Until we achieve breakthroughs in embodied AI and cheap robotics, which is bounded by battery density and hardware costs, not just software, physical labor retains a strong moat. When we combine the ALM model with Moravec's paradox, the resulting economic phenomenon is called job polarization. If we plot job growth across the wage spectrum, we do not see a straight line. We see a U-curve. Low-wage manual service jobs are growing. High-wage cognitive, strategic jobs are growing. But the jobs in the middle, the routine cognitive tasks that pay $20,000 a month, are sinking into the valley of death. A brutal heuristic to determine if your job is in this valley is the API test. Can your daily workflow be defined by inputs and outputs? Do you receive a brief, process it according to professional standards, and send back a deliverable. If your interaction with your employer is entirely digital, through Slack, email, and Jira, you have essentially turned yourself into an API. And in the realm of software, an expensive, slow human API will always be replaced by a fast, cheap machine API. To understand where humans go next, we must look at Michael Kramer's O-ring theory of economic development. The theory is named after the Challenger space shuttle disaster, which was caused by the failure of a single, cheap rubber O-ring. The mathematical premise is that in complex production processes, the total value is not the sum of its parts, but the product. If a process requires 10 steps, and each step has a 95% success rate, the overall success is 0.95 to the power of 10, which is barely 60%. Historically, humans performed all 10 steps. Now, AI can perform 8 of those routine cognitive steps with near-perfect reliability and zero marginal cost. What happens to the remaining 2 steps? Their value skyrockets. In a multiplicative equation, if 8 variables become a constant of 1, the entire output depends exclusively on the quality of the remaining variables. The human is no longer the processor of the routine steps, the human becomes the critical O-ring. Your value is no longer in writing the code, but in deciding what code needs to be written to solve the actual business problem. This leads to a new paradigm of work, categorized by researchers into Centaur and Minotaur workflows. A Centaur divides the work, the human does the strategic, ambiguous tasks, while handing off the structured, routine tasks to the AI. A Minotaur integrates deeply, the human and AI work in a tight feedback loop, co-creating at every step. If you are trying to compete with AI on pure output speed, you will lose. You must become a Centaur, elevating yourself to the orchestrator layer. But we must acknowledge a dark macroeconomic reality. Even if you become a brilliant orchestrator, the overall demand for middle-tier labor shrinks. This exacerbates the decoupling of productivity and wages. Since 1979, productivity has grown exponentially, while median wages have stagnated. AI acts as a hyper-accelerator for this trend. The economic gains of AI-driven productivity will disproportionately flow to the owners of the capital, the compute, the data, the models, rather than the providers of labor. In economic terms, this is a massive shift in the factor shares of national income. Historically, labor captured about 65% of GDP, and capital captured 35%. As AI replaces cognitive labor, intelligence itself transitions from being a property of labor to a property of capital. When intelligence is capital, the labor share of income will inevitably crash. The $20,000 a month job isn't just disappearing, its economic equivalent is being transferred onto a corporate balance sheet as a depreciating software asset. Optimists will point to the lump of labor fallacy, arguing that human desires are infinite. If AI makes software and content incredibly cheap, we will simply demand vastly more of it, creating new jobs to manage this abundance. Just as the invention of the spreadsheet didn't kill accountants, but allowed them to run vastly more complex financial models. This is true, but it misses a critical nuance regarding the speed of adaptation. When the tractor replaced the ox, the farmer had a generation to learn to drive. When the computer replaced the typewriter, the typist had a decade to learn word processing. The current AI revolution operates on an exponential curve where the half-life of a technical skill is measured in months. The bottleneck is no longer the creation of new tasks, but the neuroplasticity of the human brain. How many times can a middle-class worker completely reinvent their cognitive skill set before they simply cannot keep up? Yet, economics offers a glimmer of hope through David Ricardo's law of comparative advantage. Even if AI becomes absolutely better than humans at everything, including both cognitive synthesis and physical robotics, it will still make economic sense for humans to work. Why? Because AI compute is a scarce resource. It will be deployed to solve the highest value problems first, like curing cancer or optimizing global logistics. The lower value tasks, even if AI could do them better, will be left to humans simply because our opportunity cost is lower. This forces a profound philosophical pivot. For the last century, the education system trained us to be processors. We were graded on our ability to store information, apply logic, and output correct answers, essentially, acting like biological computers. As AI commoditizes intelligence, the premium shifts from intelligence to agency. AI has the capacity to solve problems, but it has no intrinsic desire to do anything. Humans have the want. We have the intent, the vision, and the liability. Consider the concept of liability. An AI can draft a perfect architectural blueprint, but an AI cannot go to prison if the building collapses. Society requires a human to sign the blueprint, to absorb the risk, to put their reputation and freedom on the line. In a world of infinite, cheap intelligence, the ultimate scarce resource is accountability. The surviving middle class will not be paid for generating the work, they will be paid for taking responsibility for the work. Furthermore, we must recognize the intrinsic value of shared human experience. Why do we still watch human athletes run marathons or play chess, when a car is faster and a computer is smarter? Because we are watching the struggle of a biological entity bound by the same limitations we have. Empathy cannot be automated. The jobs of the future will heavily index on human connection, nursing, teaching, coaching, and community building. The $20,000 a month job will shift from staring at a screen to looking into another human's eyes. We may also see an artisan revival. Just as the mass production of cheap furniture created a premium market for handcrafted, bespoke woodwork, the mass production of synthetic cognitive content will create a premium for verifiable, human-made thought. When AI can write a perfect, soulless email or essay in a second, the messy, idiosyncratic, and deeply personal human voice will become a status symbol. Imperfection will become the hallmark of authenticity. So, where do we go when AI devours the middle tier? We go up, to become orchestrators of complex systems and bearers of liability. We go down, to the physical world where hardware still struggles to match millions of years of evolution. And we go inward, to the uniquely human domains of empathy, connection, and authentic creation. The hollowing out of the middle class is not the end of human utility. It is the end of humans acting like machines. We are finally being forced to figure out what it actually means to be human. The transition will be brutal for those who cling to the old paradigm of routine cognitive labor. But understanding the underlying mathematics and economics is the first step to surviving the shift. I am Lemma, and on this channel, we strip away the hype to look at the hardcore logic driving our future. If this deep dive changed how you view your own career trajectory, hit the subscribe button, leave a like, and tell me in the comments, what is your strategy to become the critical O-ring in your industry? See you in the next one.